All right, guys, welcome to lesson 7.3. We're going to talk about complex fractions today. So let's go ahead and get started there. First of all, let's talk about what a complex fraction is. A complex fraction is basically a fraction in which the numerator and or the denominator is a fraction. So, for instance, well, let me read it again just to kind of say it a little bit quicker now. A complex fraction is a fraction in which either the numerator or the denominator itself is a fraction. So we're used to fractions, that look like this, for instance, 3/4. But if I take that 3 there on the top, and let's say I change it to a 3/5, well, now I've got a fraction in my numerator, right? That's weird, but that's what a complex fraction is. So here's an example of a complex fraction. All right, it's a fraction basically inside of another fraction. So how do we simplify complex fractions? So basically we're going to multiply the numerator and the denominator of the big fraction by the denominator of the little fraction. So what do I mean by that? Well, let me give you, let's go back to our previous example. I had this example up earlier. It was 3/5/4. That was our complex fraction, okay? So let me do some color coding here. We have a big fraction. The big fraction, I'm going to trace in green. There's its bar. There's the denominator of the, actually let me write that a little bit differently. Here's the denominator of the big fraction, and here's the numerator of the big fraction, right? So we have a big fraction here where the numerator is 3/5 and the denominator is 4. We also have a little fraction. The little fraction is the one that's inside of the numerator here. I'm going to color code that as orange. So my little fraction is the orange one there. It's 3/5. Okay? So how do we simplify this complex fraction? Well, I'm going to multiply the numerator and the denominator of the big fraction by the denominator of the little fraction. So I'm going to multiply the top of the big fraction and the bottom of the big fraction by 5. Okay? So now why would I do that? Well, let's kind of show how that works out. Get rid of some of these markings here. So I'm going to multiply the top here by 5 and the bottom by 5. Now, when I do this, the bottom's going to become 20. That's pretty straightforward and simple. 4 times 5 is 20. But what's 3/5 times 5? Well, I'm going to show my work here on the side. You don't have to do that necessarily, but if I'm taking 3/5 and I'm multiplying it by 5, that's like 5/1, right? And then those cancel. And so you're left with 3/1, which is just 3. So that's why we do it. By multiplying the top of the big fraction by the little denominator there, this 5 cancels out with this 5, and I'm just left with 3. And we're done. Okay? So that's the trick there, is that we multiply the numerator and the denominator of the big fraction by the denominator of the little fraction. And when we do that, it makes the little fraction go away, so we end up with just 3 on the top now. But we also do it to the bottom, so 4 times 5 makes 20. So we end up with 3/20. That's the idea. All right? So let's do another quick little simple example, and then we'll move into the types of problems we'll be looking at today. So let's say I had this. All right, so what's the little denominator? What's the denominator of the little fraction? Well, the little fraction is this guy here that's in the bottom of the big fraction. So what's the denominator of that little fraction? It's 7. So what I'm going to do is I'm going to multiply the denominator of the big fraction and the numerator of the big fraction by the denominator of the little fraction. So I'm going to multiply by 7 here. I'm going to multiply by 7 here. Now on the top, 7 times 2 is simply 14. On the bottom, 5/7 times 7, well, the 7's cancel, leaving me with 5. Okay, so that's the idea. Now, as I mentioned earlier in my definition, what is a complex fraction? A complex fraction is a fraction in which either the numerator or the denominator, or possibly both, have a fraction. So in some cases, you could have something particularly more complicated like this, for instance. Like say I had 3/5 over 2/7. Well, now both my numerator and my denominator are fractions. And so what do we do now? Well, you multiply by both of them, basically. Just do one at a time. So first of all, I would multiply maybe the top and the bottom by 5. Why would I want to multiply by 5? Well, because by multiplying by 5, this will cancel this, and I no longer have a fraction in the top. Now, on the bottom, though, when I multiply 5 over 1 times 2 over 7, nothing cancels. So just multiplying straight across, it doesn't get rid of my fraction. It just leaves me with another fraction. So now I've got 10/7 instead of 2/7 in the bottom. But it's still simpler because by doing that, I got rid of the fraction in the top. So now what do? Well, I get to do the process again. So however many denominators you have, that's how many times you're going to have to do this. So now I'm going to multiply the top and the bottom of the big fraction by the denominator of the little fraction. So I'm going to multiply both of these by 7 now. And the reason I'm doing that is because when I multiply 10/7 by 7, these 7's cancel out, and I'm going to be left with 21 on the top and 10 on the bottom. And sometimes you'll need to reduce after that, but that's the idea. So the basic idea there is that's how you get rid of, how you simplify a complex fraction. It's just by multiplying the numerator and the denominator of big fraction by the denominator of the little one. So let's go ahead and take a look at some algebra examples. These are going to have variables in them. So this is what your homework will look like now for the most part. You're not going to have just the numbers. It's going to have some variables, but it really doesn't change the process. So here's the big fractions fraction bar. Here's the numerator of the big fraction, and here's the denominator of the big fraction. And so we have two little fractions. I've got a little fraction in the numerator, and I've got another little fraction in the denominator. And I want to get rid of those fractions. I want to get rid of their little denominators. So the way I'm going to do that is I'm going to multiply the top and the bottom of this big fraction by those little denominators. And I'm just going to do it one at a time. So let's multiply. So first of all, let me get rid of the 9 first. So to get rid of that 9, I'm going to multiply the top of my big fraction by 9 and the bottom of my big fraction by 9. Now when I multiply the top of my big fraction by 9, these cancel, which is what I was trying to accomplish. And it leaves me with just one letter now on the top. No longer a fraction, but just a single term. Over. Now on the bottom, nothing cancels out. Okay? So since nothing cancels out, then we just multiply straight across. A squared times 9 is 9a squared. And 4 times 1 is 4. So I still have a complex fraction, so now I get to repeat this process. So here's the numerator of the big fraction, and here's the denominator of the big fraction. And I want to get rid of the little denominator. So I'm going to multiply the top and the bottom now by 4. And that will cancel that 4 out there. And on the top, it's going to leave me with 4a. And on the bottom, it's going to leave me with 9a squared. Okay. After you do that, you may need to reduce. So at this point, we can reduce. These are monomials. So I can't do anything with the coefficients. So the coefficients stay the same. It's still 4 over 9. But I can reduce these a's. I've got a to the first over a squared. So we subtract 2 and 1. 2 minus 1 is 1. So it's going to be a to the first power. And since the bigger power is in the bottom, the a to the first power goes down here on the bottom. And now we're done. So that's the basic idea. Let's take a look at another example, and then I'll let you guys try one. All right. So once again, I have my, it's kind of hard to find out where it is. I wish they would make the fraction bars different sizes, but you can kind of tell that that's the fraction bar for the big fraction. There's the numerator, and there's the denominator, right? So let's go ahead and get rid of this little denominator first. So I'm going to multiply the top by m, and I'll multiply the bottom by m. It might help you guys to put it over 1. I haven't been doing that so far, but it might help you to do that because we are multiplying fractions. And so it's important to understand when you're multiplying fractions, it's top times top, bottom times bottom. So in this case, these are going to cancel. And all I'm going to be left with then on the top is m plus 3. And for this one here, nothing cancels out. Now, I hope you guys aren't thinking m cancels m, right? Because we talked about how you can't do a plus b over a and have those cancel because that plus joins the a and the b together into a whole. So you can't do that. Common mistake, but so you can't do that. Let me back up a little bit, actually. All right, so instead of canceling them, we're actually going to multiply. M squared times m leaves me with m cubed. And on the bottom, I have m plus 3. All right, so I still have a complex fraction, though. I've got a numerator and a denominator. And in this case, the denominator is a little fraction. And so I don't like the denominator of the little fraction being there. So I want to get rid of that m plus 3 on the bottom. So I'm going to multiply this fraction on the bottom by m plus 3. Once again, you can put it over 1 if you want. I'm not going to put this one over 1, though, because these aren't fractions on the top. So I think it's better just to leave it like that. But in this case, these are going to cancel out. And I'm going to be left with a nice simple m cubed on the bottom. On the top, we have this. Now, I'm not sure if my software is going to write this as an answer. It might. You know, so on a multiple choice test, it's possible they'll have that. It's also possible that they'll work it out. This was a shortcut we learned a little while back. I don't know if you guys remember how to do it, but let's review it now. It's you do the first times the first. You do the last times the last. You do these two multiplied together and double it. You could also just do the box method. It will work, but if you have a shortcut, use it. So they might write the answer like that. Or they might even write this one like this. Instead of putting m plus 3 times m plus 3, they might just do this. So you kind of have to be prepared for all the different ways that this answer could be written. But there's the idea. So that is simplifying complex fractions. Let me go ahead and toss a couple of these your guys' way. All right, so go ahead and pause the video here and see if you guys can get the correct answer. All right, and so there's your answers for those two problems. Number 4 is interesting because we have the same denominator written in both spots, and so when you do your multiplication, it actually cancels them both out simultaneously. So you only end up having to do it once. All right, let's go ahead and move on to a new topic here. Now, we're going to look at another situation now, and this is a situation where we have not just one fraction in the numerator and one fraction in the denominator, but we actually have more than that. In this case, we have one fraction in the numerator, but my denominator actually has 2 fractions Okay, and so that complicates things a little bit. All right, so I want to take back that statement. It doesn't necessarily complicate things. It just means we have more to do, right? So basically, for every little denominator you have, you're going to have to multiply by that many denominators, or will you? So there's actually a little bit of a catch there. I'm going to show you guys two ways to do this problem. One way is the longer way, one's the faster way. You might think, well, why'd you just show me one? Well, there's a reason. I want you guys to be prepared for every circumstance, because sometimes this faster I'm going to show you won't work. But let's start with the longer way. So first of all, let's say I want to start by getting rid of this 2. So if I want to get rid of this 2, then what I have to do is I'm going to need to multiply this entire denominator by 2 over 1. And I also have to multiply the numerator by 2 over 1. All right? So in this case, nothing really cancels per se, but we can have 2/8, right? And on the bottom, if we distribute this, well, that's kind of the new part. This 2 over 1 has to be multiplied by both of these. So in other words, it's going to look like this. U over 2 is going to be multiplied by 2 over 1. And U over 4 is going to be multiplied by 2 over 1. Okay? So you're going to distribute that 2 over 1 to both of them. Now in this case, the 2's cancel, right? In this case, we can't directly cancel anything out, but I want to show you what we can do. Here I'm left now with just a U. It's U over 1, but I'm just going to put U because you can. And then here, top times top, bottom times bottom gives me 2U over 4. So I've successfully gotten rid of one of my denominators. Okay? Now you can just keep doing that. So I can multiply everything by 4 now if I wanted to. So suppose I want to get rid of this little denominator. Okay? So what I would do is I'm going to multiply the top and the bottom by 4. That's going to give me 8 over 8. And then when I distribute this, 4 times u is going to be 4u. And then when I distribute it in here, those are going to cancel out. And so I have this. Now you guys probably have already caught on to something here that I've not been doing, but that's okay. You'll see it in a minute. But now I've gotten rid of some fractions that way. Now some of you guys might have noticed something though. You may have noticed, Mr. Bailey, you could have saved a heck of a lot of time if maybe you just reduced as you went. Like for instance, I'm not done yet by the way, but why didn't I change that to 1/4? I could have. Why didn't I change this to 1/2? I could have. If you reduce the little fractions as you go, it could save you some time. But I'm not going to go back and do it again. I just want to show you. You can reduce as you go. And in fact, that's what I'm going to do here. Instead of multiplying the top and the bottom by 8, which is what I could do, right? I could multiply the top by 8, and I could multiply the bottom by 8. I could do that. But another thing that we can do instead is, how about instead of multiplying the top and the bottom by 8, we just get rid of this fraction by doing something else. What is 8 over 8? 8 over 8 is 1. Right? There's no need to do anything to get rid of that fraction. It actually reduces itself away. So you could do that. And my final answer here would be 1 over 6u. Okay? So that's one way you can do it. It's a little bit longer, but basically just multiply everything by each little denominator. And if you can, reduce as you go, and you'll eventually get there. I think the big thing I want you guys to be aware of with this is that when you multiply the denominator by something, you're distributing it to both terms, right? We distribute it in. Now I want to show you guys a faster way to do this though. That was the long way. Let me show you guys a faster way. The faster way is to actually start by multiplying everything by the biggest of the little denominators. So I've got three little denominators here. I've got an 8, I've got a 2, and I've got a 4. Now, which one of those is the biggest? Now, that's probably not the best way to word it, although in this case it helps. You guys know the answer is 8, right? But a better way to word it is which one of these little denominators will cancel out the most stuff. And the answer is, in this case, it's going to be 8. So let me show you why. So I started off last time by multiplying this guy here. But if you actually start by multiplying the biggest little denominator first, so I'm going to start by multiplying by 8 this time, watch what happens. Those cancel, so my top is 1. And when I distribute this inward, I'm going to end up with 8u over 2 plus 8u over 4. Now, instead of doing any more multiplication, we can just reduce. 2 goes into 8 4 times. So 8u over 2 becomes 4u. 8 divided by 4 is 2u, and that's a lot easier. So here's my recommendation for handling these problems, is to multiply everything by the denominator that will end up canceling the most stuff out. You know, because 8 not only will cancel itself out, right, but it can also be divided by 2 and 4. So whenever you multiply by 8, it's going to cancel more things out. Okay? So multiply by the biggest denominator, or the denominator that will end up canceling the most stuff. Okay? Let's go ahead and take a look at another sample problem here. All right. So for number 6, I have 3 little denominators. I've got x squared, I've got x, and I've got x plus 5. Now, which one of these will cancel the most stuff? Well, x plus 5 is kind of its own little thing. Nothing's going to cancel x plus 5 except for x plus 5. But let's look at x squared and x. X squared, if you start by multiplying everything by x squared, not only will it cancel the x squared, but it actually can also cancel out this x as well. So I'll show you what I mean. So I'm actually going to start by multiplying my numerator and my denominator by x squared, because that one, I can tell, is going to cancel the most stuff. Now this is just a faster way to do it, so if this is kind of hard for you to discern, it's not a nail in the coffin. You'll still be able to solve the problems using the strategies I've shared with you before, but it's just nice to know the faster way. So I'm going to multiply the top and the bottom by x squared first. So those cancel, leaving me with a 5 on the top. And on the bottom, if I distribute this x squared in, 25 times x squared is going to be 25x squared. And 1 times x plus 5 is just going to leave x plus 5 the same. Minus x squared times 1 is going to give me x squared. And 1 times x is going to give me x. But notice here, I can reduce that. X squared over x. That simplifies into just simply x. So by me wisely choosing to multiply by x squared first, I actually ended up killing 2 fractions at once. I not only killed the fraction on the top, but I also killed the 1 over x on the bottom. So it saves me some time. But when it comes to the x plus 5, we're kind of stuck with having to do that one as is. So I'm going to multiply the numerator and the denominator by x plus 5 now. Okay, so on the top, 5 times x plus 5, you're going to have to distribute that 5 inside. Matter of fact, let's wait on that for a second, because we might want to reduce at the end, and leaving it in factored form could be helpful. So we'll leave it like this for now. On the bottom, when we distribute this in, this x plus 5 is going to cancel with that x plus 5. Okay? And so that's going to leave me just with 25x squared. But we also need to distribute the x plus 5 in here, so it's going to be x times x plus 5. Now, if it helps, I could kind of show you the step a little bit more clearly, because I am doing quite a few things there. So we originally had 25x squared over x plus 5, right? And I distributed into the parentheses x plus 5 over 1. And then we had x, and I distributed into there also the x plus 5. So I put the x plus 5 into both pieces, and here they canceled, and so that's how we're left with what we have over here. So now at this point, we're going to need to simplify the bottom a little bit. I'm going to distribute this x in, and be careful, that's not just an x, that's a minus x. So we're going to be distributing a negative x into those parentheses. Okay. I do see some like terms I can combine here, so let's do that. 25x squared minus 1x squared is going to leave me with 24x squared, so and I'm pretty sure this problem is done. The only thing I can see is that I could factor an x out of the bottom here, and I would see if maybe I can cancel that with something on the top, but it's not going to cancel anything out. So I would just leave it like that. So they'll probably have the answer written like this, or they might take the trouble to distribute this 5 into the parentheses. I doubt it, but it's possible, in which case you could also have the answer written like this. But factoring isn't going to reduce, so we'll skip it. Okay, so that is your second example for those types. Let's go ahead and get you guys some to look at. All right, so here's a couple for you guys. Go ahead and pause the video here and see how you guys do with simplifying these expressions. All right, guys, so I'll let you go ahead and study this here. The answers are in the boxes there. So for the number 7, it's x cubed plus x cubed plus 16 over 4x squared. And for number 8, the final answer is 3 parentheses x plus 1 over x squared plus x plus 81. One little thing I would point out is that on number 8, I started by multiplying the top and the bottom by 9, because that is the one that would cancel the most stuff. Not only would it end up canceling out the 9 here, but 9 over 3 reduces into 3. So it ends up canceling out 2 fractions. But other than that, it's all pretty standard from what we've looked at. I'll let you guys go ahead and study it and see what you got right and what maybe you need to correct. But other than that, it closes out our lesson for the day, and we'll see you guys next time.